All right, hello and welcome to Unit 5, Lesson 1 on angle bisectors. So this unit is all about special segments in triangles, and today we're going to learn about the first special segment, and that segment is an angle bisector. So an angle bisector is a segment that literally cuts an angle in half. You can see that these angles are marked congruent because this big angle has been cut into two congruent pieces. Therefore, it has been bisected. We already know this. We've learned this before. How do we know if AD is an angle bisector? We know it if there's two congruent angles, okay? So we draw the angle bisector to the opposite side of the triangle, so it stops on the edge of the triangle. And I want you guys to understand that it doesn't necessarily split the side in half. Like, these pieces are not congruent. BD and DC are two different lengths. The angle bisector only cuts the angle in half, and that's an important distinction. So the first thing that we do is we draw in angle bisectors. So let's draw the angle bisector of angle D. So, we are going to go ahead and, I like it to start right here. And all right, so now look, I want to move this around so that it looks like it's right in the middle of that angle, splitting it in half. Okay, I'm going to draw it to the opposite side. And it's not an angle bisector until I mark that these two angles are congruent. You have to mark the angles are congruent. Okay, next we're going to do the second triangle, angle E. So I'm going to put a point on angle E, and I'm going to draw a segment from that. And again, I'm going to move it around so that it looks like it's perfectly cutting that angle in half. That looks like right about there. It doesn't have to be perfect, but it should somewhat look like these little angles are congruent, and I'm going to mark that they're congruent with arc marks. Finally, angle F, last but not least, we're going to take angle F, and again, we're going to cut it in half. So again, we want it to look like it's going right down the middle and mark it. So it doesn't matter if you mark the angle with one arc mark, two, if you do the tick through it or not, doesn't matter. Just mark for me that they are congruent in some way. So example 2 says draw the angle bisector from each angle all in the same triangle. So let's start from angle B. Okay, again, just make it look like it is two congruent angles, this one and this one. Okay, now I'm going to do it from angle A. And again, just make it look like it's getting cut right in half. Mark it congruent. Then we got it. And then last, but certainly not least, we got from angle C. And again, we just want to make it look like it's kind of going right there. Now, if you do it right, these are all going to meet at the same point. So notice they all meet at the same point. That's kind of true about all these special segments. They all are what we call concurrent, meaning they will intersect at the same point if we do it right. Okay, and this point does have a special name, but we don't really talk about it with angle bisectors. We do talk about it with some other special segments that we'll get to later in the chapter. So that's the big thing, is just what is an angle bisector, drawing those and making sure that we mark everything congruent. Now there's an angle bisector theorem. That's the second big part of these notes. The angle bisector theorem says this: if I have an angle bisector, so this one is an angle bisector, and I know that because the angles are marked congruent, then no matter where I draw a point on the angle bisector, so it could be down here, it could be up here. In this case, the point is point D. That point will be what we call equidistant to the sides of the angle, meaning like this distance, which is the shortest distance from the point to the side. That's why this little right angle is there. That just indicates that's the shortest distance. And this distance are the same. So let's say this was 5 units, then this would also be 5 units. So DE is congruent to DF, and that is the angle bisector theorem. All right, so example 3 says this: if AD is equal to 5 and DC is equal to 5, all right, well, since these are equal, that means that I know for sure that this ray is the angle bisector, and that's just because of the angle bisector theorem. If a point on a ray is equidistant from the sides, that means it's lying on the angle bisector. All right, so ABD is 14 degrees. Then it says find the measure of ABC, the whole thing. Well, if this is 14 degrees down here, that means this is also 14 degrees since it's an angle bisector, which means the whole thing is 28 degrees. That's the answer. That's example 3. Okay, example 4 says that BD does in fact bisect angle ABC. Use the angle bisector theorem to solve for X. Okay, so we know this is an angle bisector, which means that these segments drawn in are going to be congruent, which means all I have to do is take these and set them equal to each other. So we have a 14x minus 8 is equal to 11x minus 2. And then we just have to solve the equation. So I'm going to subtract over 11 with the x. And so then I get 3x minus 8 equals negative 2. Next, we're going to add this 8 over to the other side. We get 3x equals 6. And then that means x, if I divide this 3 over, x equals 2. And the question just asked for us to solve for x, so that's what we did. X is 2, and that's that. And then, of course, we have to do a quadratic at some point. So this one just says, in the diagram below, ER is congruent to EN. So if I know that ER is congruent to EN, since E is on this ray, I now know that that ray is an angle bisector since these segments are congruent. So that means that this angle is congruent to this angle. So solve for x and find the measure of angle OAG. All right, so I can say x squared minus 12 is equal to x, the other angle. And this is a quadratic, so I'm going to subtract the x over to the other side, put it in the middle, and factor. So what multiplies to negative 12? That adds to negative 1. The numbers are 3 and negative 4. So x plus 3, x minus 4 equals 0. And then I'm going to solve. So I'm going to set each of these parentheses equal to 0, get x by itself. So x is negative 3 and x is positive 4. But of course, the negative is not going to work because if I plug it into this angle, I get a negative angle. All right, so then if x is 4, that means this angle is only 4 degrees. And if I plug it in here too, it should work out. 4 squared is 16. 16 minus 12 is 4 degrees. So the math is mathing. They're both 4 degrees. So that means that OAG, which is this whole entire angle, is 8 degrees. And that's that. So it was a pretty quick lesson. I know I went quick, but you can always pause, rewind, rewatch. That's really the gist of it all. So angle bisector. And we're going to move on to different types of segments next week. Thanks, guys.